Yeah, good evening. So today is our first class after completion of our demos. So from today we are going to start the actual syllabus. Like our first chapter is introduction to data structures and algorithms. Then we have to see analysis, how you can able to analyze the algorithms, what are the various steps are there for analysis purpose, and how we can calculate complexity of algorithm. Generally, time complexity, space complexity, we are going to measure, right? Part we will see, and Python inbuilt data structures. Okay, and even array module. So list, so up to strings, up to these 9 chapters. Just we are going to revise whatever concepts are there in Python. Moreover, Python internally it supports the concept of data structures because you
Sorry, your voice is cracking.
we have list data structure is there. Okay.
Sir, your voice is being spoken.
Sir, is my voice is audible?
Right now
Yeah,
you
yeah.
are audible,
Just a
sir, but
second. Now is it okay?
yes, sir.
1 second. I will change the network. 1 second. Yeah, now tell me, am I audible? Please confirm now. Am I audible? Yes, requesting everyone to please confirm. Now, am I audible, sir? Please confirm. Right. Right. Now let us go for the execution process. So how we are going to cover all these things step by step, I will explain. See, as a part of today's session, sir, this is the permanent link. Okay, this is the permanent link, and don't share this link with anyone, because if any person joining with this link, then so with their email IDs, it will be get registered. You won't get any access for the next link. That's why. So please don't share this link with anyone. Moreover, in the groups also don't share this. Okay. Now, coming to our first chapter after demos, what is the first chapter here we are going to discuss is introduction. Okay, introduction to data structures, introduction to data structures and algorithms. We are going to see what is mean by data structure and what is mean by algorithm. See, generally, in general, I am talking in general, whenever you are getting any problem, what we have to do, sir? So we are going to think about that problem. Okay, if I want to solve any problem, first we will think about that problem. Once if you think, you are going to get some idea to solve that problem. Okay, if you think what will happen, you are going to get some idea to solve that problem. Okay, so suppose even if you are thinking, if you are not getting idea, then what we are going to do at that situation, we are going to prepare some algorithm. We are going to prepare some algorithm. Sir, what is the meaning of algorithm? So we can say it is nothing but a step by step process for solving a problem. When you are solving, if you are unable to get the solution, then you can able to prepare the algorithm, sir. Okay, so it is going to give some easiness. Still, if you are not getting understand, we have to go for flowchart. Do you know, in my general classes, when student is asking me to explain that particular logic or that particular problem again, what I'm going to do is I will convert that one into, so one diagram I'm going to take. Like if you represent anything in diagrammatic format, so it is very easy to understand. Okay, that is the meaning of flowchart. Flowchart means what? Pictorial, diagrammatic representation of an algorithm is called as what? Flowchart. Sir, what advantage we are going to get? Very simple, sir. Diagrammatically, if you see, then the problem statement will become very easy. Okay, next, after completion of all these things, we will go for a program, and once if you execute the program, you will get outputs. Okay, this is nothing but the general sequence what we are going to get. When you have a problem, so you have to think about the solution where we have to apply some idea. Suppose if you are unable to get, you can go for algorithm. Then still if you are unable to solve that problem, better to go for flowchart. Then after constructing the flowchart or algorithm, or if you have an idea, then you need to convert that into program. So later that program will be executed and it will display the output, sir. This is nothing but the general process for any programming language. So how to solve the problem? Are you clear with this problem solving approach?
Yes,
Yes,
sir.
sir.
Everyone please confirm. Is it clear?
Yes, sir.
Right. So now, sir, if I want to prepare any algorithm, how to how to prepare? What are the steps and what things we need to understand? See, if I want to go for algorithm, what is the definition of algorithm? In the sense, very simple, step by step process. Okay, step by step process to solve a problem. Step by step process to solve a problem is called as an algorithm. Step by step process to solve a problem. I want to perform addition of two numbers. So here I need to calculate addition of two numbers. What steps we have to apply for this? Very simple. The first step here is we have to read A and B values. We have to read A and B values from the user. Right? A and B in the sense, just for your understanding purpose, we are giving two names. What is the first name? A. What is the second name? B. We have to read these two values dynamically from the user. This is the first step. Sir, after reading the value of A and B, what is the next step? We have to compute. We have to compute or we have to calculate C is equal to A plus B. Okay, after computation, okay, we have to, after reading the data, we have to compute C is equal to A plus B. We are adding the value of A and B and we are assigning that result to the C. This is nothing but my next step. Then after this, what we have to do? We need to print A comma B and C values. That is nothing but what? Output. Okay, we have to print A value, B value and C value on the screen. So these are the three general steps what we have to apply if you want to calculate addition of two numbers. Just general program I explained. Sir, now if you are okay with this algorithm, I will explain flowchart. Sir, what is mean by flowchart? So maybe I think you have seen already pictorial representation. Pictorial representation of an algorithm. Pictorial representation of an algorithm is called as flowchart. Pictorial representation of algorithm is called as what? Flowchart. Means what? Diagrammatic representation. Once if you have algorithm, still if you are unable to understand the concept of algorithm, you can convert that into flowchart, sir. That is called as what? Pictorial representation. Pictorial, diagrammatic representation. Sir, I want to see this addition of two numbers program algorithm, sir. Sir, very simple. We can write, but of course it is not as of now our business. Just I am going to take so diagrammatic representation for this. You can see, sir, somewhere. Okay, can I take this one? Yeah, this one is a bit easy. You can see here. Yeah, have you observed? There are some special symbols are there, like one is to start, another one is to end, and input number one and number two. We are reading two numbers like number one and number two, and we are calculating the sum. What is the value of sum? Number one plus number two. These two values we are adding and we are printing the result. This is nothing but what we have. So a simple diagrammatic representation of this algorithm is nothing but what, sir? Flowchart. I think you got clarity about this. Just as of now, I'm not going in depth. So what is mean by algorithm? Because as a programmer, we have to see from the scratch. That's why just I am explaining the low level. What is algorithm? What is data structure? This theoretical part I am covering. So just 2 points we covered. What is algorithm? How to develop the algorithm? What is a flowchart? Why we need to go for the concept of flowchart? So if these two things are clear, then we are ready to go for implementation of this program. Sir, if you are clear with these two definitions, I will go for the next step. Are you clear with these two? Please confirm.
Yes.
Yes.
Right. So what is the next step? So we have to go for implementation. Sir, how you can able to implement this program? Sir, once implementation. So once if you are clear with algorithm and flowchart. So once if the problem statement, if the problem statement is clear and we can develop an implementation for the given problem by seeing algorithm by seeing algorithm and flowchart we can go for implementation. See, we have taken example like addition of two numbers, right? I will implement the program for this purpose. See, assume I am taking a is equal to int of input, within bracket I am asking enter a value, something like this. So b is equal to I am taking int of input and within brackets I am giving enter b value. So what is the meaning of this? We are reading the value of a dynamically from the user. Dynamically in the sense, while executing
Sir, you are not audible.
so there you have to provide b value. Sir, once if the a value and b value is given, we can calculate the value of c. Sir, how to calculate the value of c? Very simple. I am taking c is equal to a plus b. Like this I am taking. We are computing the value of a and b. We added and result we are storing into the c value. Can I print all these values at a time? Yes, there is a formatted string style is there. I want to print a is equal to what is the value of a, comma, b is equal to what is the value of a b, and the result is equal to what is the value of c. So we are printing the value of a, we are printing the value of b, and we are printing the value of c. These three values we are printing here. So now let us see how we can able to execute this. Already I told how to execute a simple Python program. Just we have to take py space test.py. What will happen? The program is going to execute. It will ask enter a value. Assume I am giving 111. Enter b value. I am giving 222. The result what we are getting is nothing but a is equal to 111, b is equal to 222, and result is equal to 333. Like this we are getting. This is the way how we can able to perform addition of two numbers by using a simple Python program. For this, I developed algorithm as well as I developed flowchart, right? Okay. So this is nothing but what we have. A simple problem I explained in a beautiful manner. Sir, are you clear with this? Of course, it is a known concept for you. Just a kind of revision. Are you clear with this?
Yes, sir.
Yes, sir.
Only few
The
people are.
print statement, I was confused. Print. Inside the print, how you are writing.
Yes, yes. Already it is a. Do you know Python?
Yes, sir, but I did not use that format.
It is a formatted string, madam. It is a formatted string. What is the purpose of formatted string? Is if you take this string, inside this, something is there with flower brackets, right? So whatever is there inside flower bracket, that value will be replaced when you are executing the program. So that means what? A is equal to within flower bracket we have taken a. That means what? It will substitute that a value at the time of execution. And when we are taking b is equal to something like this, so whatever there in the flower bracket, it will substitute that value. And even result is equal to whatever you have given within flower bracket, it will substitute. This kind of formatting is there in Python. That's why if you begin with F, automatically when executing, these formats will be applied and then you are going to get the result. Got it, madam?
Sir, thank you.
Yeah, right.
Sir, instead of F string, we may use replacement operator also.
Sir.
Sir, instead of F string, we may also use a replacement operator.
Yeah, you can use replacement. But replacement operator, if you want to use, again, we need to use dot format, something like that, right?
Yes, sir.
So that is somewhat difficult when compared with this, right? This is
Right.
easy. Anyone can understand.
But sir, sometimes it's a little bit confusing. If
That
you are
one
not
is
providing,
confusing.
in my point of view, this is confusing because if you are not providing any argument, then it's a little bit harder.
No, sir. No, your assumption is wrong. See, if I want to use the same thing in I mean replacement operator, what you have to do? Just you have to remove this A here, you have to remove this B here, and you have to remove this C here, and here you need to take a dot format of A comma B comma C. Am I right?
Yes, sir.
So number of arguments is important. Mapping is also important. So these things we have to take care. Are you getting my point?
Yes, sir.
So when compared with this one is very easy. The only thing is what value you want to substitute directly you are providing here.
Got it.
Not that much difficult. So, but here what we are going to do, we have to search. Is it coming under which number? So if you take B, it is in sequence which number it is. First replacement operator, second replacement operator. That means in the second argument you have to give B. By mistake, if you are replacing with some other value, what will happen? The total result is going to be disturbed, right?
Yes, sir. Got it.
So this one also we have to concentrate. But here such a type of headache is not there. Simply you can substitute there itself its value. Okay.
Okay. After learning from you, sir, DSA in Python, definitely I will use this F string.
Yeah, very good, sir. Right. Sir, next, sir, please don't get bored because the first 2 to 3 days complete theory will be there. Okay. Please be prepared for that. Okay. So next term, we have to see what are the advantages. advantages of algorithm. Definitely some advantages will be there. Otherwise, we won't go for algorithm concept at all, right? So what is the advantage that we are going to get is the first advantage, the problem statement. The problem statement will be simplified, sir. Okay, when a big problem statement is coming, once if you prepare the algorithm, that problem statement will become very easy. Sir, do you know in my logic based programming classes, especially in my logic based programming classes, sir, we have some programs are there. If you see, you can see, sir, program number 203. How much big statement is there here? You can see almost 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines problem statement itself is there. Sir, while reading the problem statement one by one, better to write down the points so that what will happen? This entire paragraph if you convert it into algorithm, it will become very easy to read. Okay, so that's why we will prefer algorithms for that. Okay, so by using algorithm, what advantage we are going to get? The problem statement will be simplified. From that, it is very easy to understand. Okay, it is very easy. It is very easy to understand the problem statement. It is very easy to understand the problem statement. Next, and after that, so if the problem statement is very easy to provide implementation by using any programming language. So here we can concentrate on implementation rather than the confusion. Okay, so we are not required to think about the problem statement. Once if you have an idea how that problem we can able to solve, if you have an idea, no need to think about the solution. Directly we can write by using any programming language. Okay, and most importantly, so we will get a format, we will get a format, or we will get a template, or we will get a pattern to solve the problem, right? To solve the problem. Suppose today I'm explaining one program in my regular classes. I will explain how to calculate maximum of three numbers. Then immediately I may give maximum of four numbers. Immediately I will explain maximum of five numbers. And if I am asking the students, you have to submit an assignment tomorrow for maximum a minimum of two numbers, minimum of three numbers, minimum of four numbers, maximum and minimum of five numbers, maximum and minimum of six numbers. It is easy for them. Why? Because I covered three programs. If he observed all these three programs, if they prepare algorithm for that, so you will get a format, you will get a format or a template. So by seeing that, you can work for any new problem also. So generally our trainers especially, we are very what you can say, very frequently we are going to write the programs. Definitely every day we will do the same activity. So tomorrow if a new problem is coming, easily we can able to solve that. The reason for that is nothing but we have seen so many problems, so we know the pattern of the program. So if any new problem is coming, we will divide. Oh, this comes under this category, like that. We can able to divide and we can solve. So how it is happening? Because of seeing the algorithms. So this is nothing but, so we have so many, but these are the main advantages of algorithm what we have. And even so, algorithm should provide some properties. You should not write algorithm or a program directly. It has to follow some properties. What properties are there? The first property is nothing but every algorithm should take either zero or more inputs. So if you are developing any program or any algorithm, compulsory it should take no inputs or at least zero or more inputs. Okay. Even without input also there are some programs. For example, if I am asking, Array, can you please write a program to calculate factorial of 5? In the problem statement itself, they have given the input. Then what is the need to calculate? So what is the need to calculate explicitly? Directly we can do that. Do you know? These kind of things are nothing but what? Zero input based programs. We are not required to supply any input. Okay. And some programs will take the input also. That means input is optional. If you want, you can provide, otherwise no need. But every algorithm or every program should produce at least, okay, so at least one output. Otherwise, writing the program itself is meaningless. So it has to give some output. Suppose if I want to print a hello message, that a hello message is nothing but output. Suppose if I am writing a program to calculate factorial of a given number, you have to print that result, whatever we are going to get. So that is mandatory, sir. That is nothing but mandatory. Please keep that in your mind. Then what is the next one is our algorithm should be deterministic. Deterministic in the sense what? See, suppose if I am running the program today, so same output should be generated. Same output should be generated even if you run, so after, okay, if you run, so again and again, if you run, again and again. Sir, I executed one program today, addition of two numbers. So 2 plus 3, 2 and 3 I have given as an input. It is giving output as a 5. After 2 years also, if you run the program, you should get same output. Then only we can say that algorithm is nothing but what? Deterministic. Like this we have. Okay. So next and after that, your algorithm should be directly written for the problem statement. Your algorithm should be so directly, clearly you have to write. Okay, I can say algorithm should be clearly written, clearly written, clearly written. You have to write the algorithms very clearly. Next and after that, so it should terminate. It should terminate at finite steps. So it should not leads to any infinite. It should terminate at finite steps. So that means what? Suppose if you are writing any program, so there should not be any infinite loops. There should be a finite loops will be there. Okay, sir. Next and after that, last property. Sir, your program or your algorithm should be efficient. That means I'm talking with respect to logic. Logic must be clear. Logic must be clear. See, when you are writing some factorial logic, your logic should be clear. So it should not make any confusion. It should be very clearly you have to write. So these are nothing but what are the advantages that we are going to get with the help of algorithm, and what are the various properties that every algorithm should satisfy. If these two things are clear, so then we can develop any kind of a program very frequently, I mean very easily, no issues at all. Can you please confirm everyone, is the theoretical part related to the algorithm, flowchart, implementation, algorithm, advantages of algorithm, and the properties of algorithms? Are you clear with these concepts?
Sir,
Yes.
Please confirm everyone.
Yes, sir.
Yes, sir.
Right, sir. Now we have different types of algorithms are there. We have different types of algorithms are there. What are the different types of algorithms? See, around some 10 types are there. The first one is sample algorithms. Okay, sample algorithms. We are going to cover the basic addition, subtraction, so division. These algorithms will come under sample algorithms. And even we have math algorithms are there. Some mathematical related calculations if you want to do. For that, some category is there, like a factorial, or if they have given 2 points, you need to calculate the distance between 2 points. Okay, if they have given some list of numbers, you need to calculate sum of that numbers. So these things will come under mathematical algorithms. Then recursive algorithms also there. Very important. More concentration must be required for this recursion part, sir, because our 70 to 80% of data structures problems we can solve by using these recursive algorithms only. Okay, 70 to 80% of the problems can be solved by using these recursive algorithms. Sir, what is recursion? How we can able to develop recursion based applications, we will see later. Okay, so next and after that, we are going to talk about divide and conquer. Maybe all these terms you have observed very clearly in the demonstration itself. The divide and conquer algorithms means what? Suppose if you are getting a problem, so if you are unable to solve that problem, then you can divide that problem into some pieces, individual pieces, and you can solve. This facility is also there. Such a type of algorithms are called as what? Divide and conquer. We are going to divide and we will combine the solution later. We are going to divide and we will combine the solution later. These kind of algorithms are called as what? Divide and conquer. Sometimes you can solve a small problem. You can't solve a big problem. Okay. In such cases, First, we have to divide that big problem into individual steps, and then we will try to find the solution. Okay. Next, and after that, even brute force. Okay, brute force algorithms also there. Anyway, I will explain about this later. Okay. Even we have backtracking. In the demo sessions, if you observe, we covered one program for 8 queens. 8 queens or n queens problem I discussed, right? That is nothing but backtracking steps will be there in that. Okay. Next, and after that, we are going to use some sorting algorithms. We are going to use some sorting algorithms. So if sorting algorithms are there, definitely searching algorithms will be there. What are the different ways are there to perform searching operation? Even we have greedy algorithms are there, and we are going to discuss about dynamic programming algorithms. Like we have so many algorithms are there, sir. These are nothing but what are the different types of algorithms which we are going to work. Okay, so this is nothing but what is mean by types of algorithms. Are you clear with this?
Yes, sir.
Yes.
Right. Okay. So these are nothing but what we have. Sir, in this session, we covered only few things like algorithm means what. Next, and after that, flow chart. Flow chart means what. So how you are going to provide implementation. Next, and after that, we have seen properties of algorithm, properties of algorithm. Next, and after that, advantages of algorithm. Then we have seen some types of algorithms. With this algorithms concept got finished. So we will see in the tomorrow's session what is mean by data structure. So classification of data structure. Like we have some linear data structures and non-linear data structures are there. So that classification is very, very important. And we will see in detail about these algorithms one by one. I mean, in detail about that data structures. Like we have list, tuple, and a set, string, array. Okay. So tree, graph, those things are there that we will discuss tomorrow. Tomorrow we will see these data structures and classification. So again, one more topic will be there, like different approaches to solve any problem. If you are getting any problem, so how you are going to solve around some, we have some 5 steps are there. So we will cover these things. So these things will be discussed in the tomorrow's session, so that our first unit is going to be finished. Okay. Right, sir. So that's all about today's session. Sir, tomorrow timings are as usual. You have to join at 7 p.m. I will start by sharp 7 p.m. Please join at 7 p.m. So 7 p.m. to 8 p.m. our classes will be there. Okay. And one more thing. So today by maximum end of the night, you are going to receive the running notes. Already our admin team provided the videos access for you people. Only running notes today night I am going to give. Okay.
Sir, in the same link.
Uh,
Means you will provide the notes in the same link, whatever the team has
no,
provided
no,
video.
no. Separate link I am going to give. So that will be given as a shared resource, sir. Just a second. I will give that Google Drive link, not link. You can check your email ID. One second. DSA with Python folder is not created. I will create. So DSA with Python batch. This is 4th batch, I think so. So what is the batch number? I forgot.
What, sir?
Yeah, 4th batch only. So DSA with the 4th batch, September 2023. So just you are going to get the running notes in this folder, sir. Okay. So I will share this folder. So once if I share this folder, you can open your Google Drive like this and just check it shared with me. There, this particular folder will be there. Okay. Maybe after completion of class, I will give that access where you can find these running notes. Daily I'm going to upload here only one file will be there. If any images are coming, I will upload that images. Okay.
Got it, sir.
Right, sir. So thank you. See you in the tomorrow's class. Thank you.
Have a nice day, sir.
Yeah, thank you, sir.